My name is Henk Witte. I work at Groenholland, a Dutch company specializing in geothermal energy. And we do a lot of research, consulting, teaching for certification, but also we develop and deliver turnkey heat pump systems to the clients. So we cover almost all aspects of geothermal energy, shallow geothermal energy. Mainly, I think, asking questions. We have a lot of specialists in the project that are very good at their own thing, but obviously we need to try and make sure that the different tasks integrate together in the correct way and that information is available to the different people at the correct time. So that is, I think, one of the main goals, and especially in a project like this where we have many different partners from different backgrounds working together, this is an essential part. Well, we are work package leader for work package 3, which has to do with developing novel calculation methods and engineering tools for heat exchangers, ground source heat exchangers. Of course, there is a lot of information about that already, but we are looking at really different type of heat exchangers like earth baskets and slinky types that are not so well known. And the calculation tools that are needed for that are lacking. So together with our partners, the Austrian Institute of Technology and EuroCAD, we're working on both advanced calculation methods, test methods, and then at the end, we want to integrate that into an easy-to-use engineering tool for consultants and designers of these type of systems. Shallow geothermal means that we don't use the earth to very great depths, where you go to deep geothermal that is used for direct electricity generation or for heating, direct heating. So we are working at lower temperatures up to depths of about 200-300 meters. The benefit is that these systems that can be used offer a very high thermal efficiency. Therefore, they reduce the amount of energy you need for heating and cooling buildings. This is important, of course, for the government to work on climate change and the energy transition, but also for the end user because it offers really economic benefits. And the advantages are that you can do it everywhere. You're not depending on specific geologies. We have several key technologies that are being developed and implemented at the different demo sites. As you know, we've got demo sites at Aran Isles, which is a house, and Galway, Bordeaux, Perugia, and in Spain, Sant Cugat. So many different demo sites, and a few of the key technologies that we can mention are new types of heat pumps, where Fahrenheit and Oxner are working on. For retrofit applications, so in existing buildings, we really need heat pumps that can deliver higher temperatures but still be very efficient. So they're looking at cascading heat pumps, they're looking at gas-driven heat pumps. On the emission side, where you are heating and cooling the space in the buildings, we have partners like Uponor that look at new emission systems that are easy to install and offer high flexibility and efficiency. But also, like I said, we are working with earth basket and other type of ground heat exchangers that are being developed in the project and will be installed in different locations, in addition to improved vertical drilling, the conventional method of doing geothermal energy in Europe, where our drilling partner CDP is looking at improving the drilling technology and reducing the cost. And then there are a number of other important technologies as a support, more like ground radar for site investigation, building information models to support the whole process of retrofitting buildings, but maybe even complete areas, and have the correct information available for everybody. So with so many partners, there is a lot of different technologies going on, and these are just a few of the important ones, I think. barriers for shallow geothermal energy are many. In many cases, it's considered to be of high cost because people don't realize that actually it adds value to your property and that it, of course, reduces the cost during the operational phase. So, you have a good economic benefit and a payback time. But also there are problems with legislation and regulation. We are working in the ground and people are usually very worried about emissions to the ground system, emissions of not only heat and cool, but maybe also leakage of the fluid that flows through the heat exchanger. And they do not consider sufficiently the emissions that are there to air or to other parts of the environment that also play a role. So in general, I think the problem of cost is one. Another problem is, of course, that it's very suited for new buildings where you have a very high level of insulation and a low demand of energy in the first place. But it's much more difficult to do in retrofit in existing buildings. And at the same time, we know, of course, that the number of existing buildings is way greater than the number of new buildings being developed. So it is really important for the technology to be able to develop new methods to allow existing buildings to use this technology and be part of a whole package of retrofitting existing building stock. Well, the European market is difficult. I'm not a market specialist, but I know that in the Netherlands it's really booming because we have decided that we want to go off the gas grid due to also seismic activity in the north. And I think maybe more on a personal level, what I find is that a few years ago, if people asked me, what do you do? And I told them I was working in geothermal heat pumps, they said, what? And now they start telling me about the system their neighbors have or they have themselves. So you notice that there is more and more impact of the technology and knowledge about the technology in the general public. And that is a trend that is really remarkable. We are mainly technically involved in work package 3, working on new calculation methods and models to work with. So this is something that for our company is very important because we can use that not only in our consulting, but also to develop products for design and calculations that other people can do. So that's just a commercial product. But I think that one of the interesting things about these type of projects is that it brings us into contact with many people and many companies from other regions of Europe and from other specialist subjects. And that really, it broadens our knowledge. And also it builds our network. And I think if you're working consulting, that is very important to have. So it brings really value to the company in that sense as well. Shallow geothermal energy is a key technology, and the great strength, but also a disadvantage, is that it's not visible. So if you think about it, people often complain about windmills in their, for wind energy in the backyard or solar farms nearby. The geothermal energy, the shallow geothermal energy, once it's there, it's out of sight. It's a little bit out of mind as well, which is a disadvantage. But the other benefit, I think, is that it's very scalable. So you can use it in large projects. In the Netherlands, we have projects where over 2,000 houses all have an individual heat pump with an individual borehole heat exchanger. And that shows you that it's scalable to large numbers or large systems. But at the same time, you can apply it for a private house as well. So the citizens, the normal people, have a benefit of it as well. And I think that is very important in this technology.